going to do, going from the design space to, you probably somewhere like this, to the manufacture space. You should look like this. There'll be no setups and maybe even no tools. So go ahead and go into Tool Library up in Manage. And then right-click on Local and click Import Tool Library. So right-click on Local and then Import Tool Library. Then find the downloaded library with the .tools extension and just click Open. And now what you're going to have is you're going to have a huge selection of tools, like pretty much every conceivable tool that it would be reasonable to use on a shopbot. At SF State, we don't have all of these tools, but if you're doing something special, we can talk about finding one, or you can get them oneself. These are not only like the sizes and shapes of the tools, like there are ball ends, and there are flat end mills. They're also different speeds, different properties that they're going to be cutting with. But yeah, so once you have that imported, the rest of the things are going to be a lot easier. So if you go ahead and click Setup, you can click New Setup. And what a setup is it's just like a folder. It's a set of operations that you do on a part. So it's when your stock is on the machine in one orientation, everything you do to that piece is going to be in one setup.
What tool did you use?
Oh, I didn't select one yet.
Okay.
I was just poking at a random one. Good question. We'll talk about tool selection later. For now, we just want to make sure it's loaded up. So click New Setup. And you notice that it's going to, by default, it's going to give you this really big block because we haven't selected our model yet. Thanks. And our model isn't everything. We're not going to be machining a Sharpie. The machines aren't that advanced yet. So just click Model and then click this thing, and the rectangle is going to shrink way down. The next thing we're going to do is we're going to select the stock box point by clicking the box point selection tool and then picking this point here. We want to pick the point, the only point where all of the arrows point to something, where there's nothing behind any of the arrows. And that's the bottom lower left-hand corner of the part. Yeah, there are 27 options here of things to click, and only one of them is the right one. Picking the wrong one could be anywhere between bad to very, very bad. Every time you see that the machine has like huge chunks missing from it, it's usually because people made mistakes at this point. Okay. So you raise your hand?
Oh, no. Okay. Actually,
So click model. Oh yeah, there's nothing. Model, and click the model setting. Cool. So now that we've selected the box point, I'm just going to finish the setup, and then I'm going to stop the screencast, and I'm going to walk around. After we've selected the box point, we're going to go to the stock, and we're going to do fixed size box with a width of 96 inches and a depth of 48 inches. And we're going to do a front side offset in the Y. Cool. I'm gonna stop the screencast. Our setup is set up. Ha. That's not even a joke. It's like a sub pun. Notice mine's called setup 4. It's because I did it 4 times. Yours is probably setup 1 or setup 2. It's not important. So now what we have is we have a frame for the machine. The machine knows it can machine anywhere in this horrible color, whatever color this is, box. And it knows that what orientation it's in. It knows that the bit is always going to be pointing parallel to the z direction because that's how the machine, it's the only way the machine can work. So now anything we do is going to be within the setup. And the first thing I think we should do is the pocket. So if we click the 2D dropdown, you can see there's 2D pocket. That's going to be what we select. And then you just click the pocket. It will turn blue. And then we're going to select our tool. This is the first time we're selecting a tool. And we can always change it later. But I'm going to select from local, ShopBot softwood. Going to scroll down to the half-inch flat bits. And I'm going to pick the half-inch flat upcut. And it's going to fill this with a bunch of numbers. Half-inch flat upcut. So upcut tools, they both spin clockwise, but upcut tools pulls the chips out away from the wood, and downcut tools push the chips back down. And for wood, a downcut tool can be nice because it can have a better edge on the top surface because it's not fraying the wood upwards. But they also start fires because they're pushing the dust back into the cut. There are also compression bits that pull up at the bottom and down at the top where the coils are going opposite directions. We have some of those too, but the settings are really similar. In fact, I might have passed around a compression bit. Yeah, I did. So this was a compression bit. As I spin it clockwise, do I still have Dwayne Cam? What was it called? I installed a webcam thing. A photo booth. Yeah, photo booth is pretty good. I had a better one. So as I spin this, it's pulling up from the, it's pulling up at the bottom and pushing down at the top. You see what I mean? So as long as your first pass is deeper than 6 millimeters or so, it will have a clean edge on the top and on the bottom. Hi everybody, it's Rob from class. So cool, that's the half-inch flat upcut. Yours will probably say 1 dash because it's the first one you clicked. And I think actually that's it for this. Just select the geometry. Oh. And yeah, we're good to go. Oh, it's doing that thing again. I'll talk to Steve about this. I don't know how to get it when it's starting over open air, how to get it to actually not plunge. And it wouldn't be that big of a deal to do it a little bit, but to do it for this many tools would be, this many students using the machine would be bad for the machine. Most pockets aren't open pockets. Okay, let's just leave it for now. I'll talk to Steve at the break. Cool. Yeah. So the defaults, I would turn on I would turn off lead in and lead out, and I would replace them with like a nice ramp, a nice 10-degree ramp. But for whatever reason, I can't remember how to tell it that just because it's over air doesn't mean it shouldn't be cautious. Because right now it's just plunging into the material, but that's not what I want it to do. I want it to ease in nicely. But yeah, we'll get to that after break. Cool. So did you import? Scroll down, down. Half-inch flat. Outside. So library. Oh, did you import? Here. Import, and then from download probably. Yeah, shop those slides. Oh. I think you select this. Now, you already have it open. And you have to, okay, click pocket. Now click OK. There you go. Oh yeah, yours is better because you don't have that cut. Great. Our models are different. The tool? Yeah. Yeah, 2D pocket, and the tool we're using is half-inch upcut. But any half-inch tool will be fine for today. We're not actually machining it. Cool. Yeah. Okay. Okay. Okay again. Beautiful. Okay, so when you're set up, okay. Saw the pen for you. Oh, no, you're good. What's great? What's that? This is awesome. Saw. Yeah. Normally we do like a tool change and use a round tool for this, but just to make the certifications go faster, we're just not doing a tool change. Yeah, that's great. It works. Cool. So yeah, everyone else's looks better than mine because I put this cut in, and I don't know how to. This is the first time I've ever machined an open pocket, and what an open pocket is a pocket where one of the walls is missing. And because one of the walls is missing, Fusion's like, oh, I don't need to be cautious here because you're not going to keep this. But those red lines that you see on yours, those are like the cautious ramping lines. So if so the one thing I want you to change is I want you to go to linking. I want you to uncheck lead in and lead out. And I want you to turn the helix to 10 degrees. So again, in 2D Pocket, on the last tab, which is linking, I want you to undo lead in and lead out and change your helix to 10 degrees. And what that means is that instead of plunging in and then going sideways, it's going to just gently ramp in with this nice angle. The default is really conservative, but we're not machining metal, so we can be more aggressive than 2. I'm actually going to go, I'm going to make my file more like yours just for a second. Great. You see that, how nice that is? Now, if we go to simulate, it's going to ramp in nice and slow. And then it's going to take out all of the material. What's another thing we have to change? Yeah, the stock to leave. Because right now it's being bad. It's not going to the edge. And it's not going to fit a pack of Post-its unless it goes to the edge. So go back into the pocket and uncheck stock to leave, which is on passes. And now if we simulate it, you can turn stock on if you want to see how it's going to look. You can see that it goes all the way to the edge. Beautiful. Cool. Next up, let's do these holes. I'm going to go 2D. I'm going to use bore. Again, we could use drilling, but it would be way worse for the bit. And since these holes are actually bigger than the bit, we can use bore. You can either click all 6 holes, all 5 holes, or you can just click one and then click select same diameter. And it will use magic to figure out which one it should drill holes in. And again, it takes all the settings from Steve's file, so we don't need to go through any of the feed and speed settings. Bore is under 2D. Yeah, everything is fine. I'll do it again. I'm going to delete it. I'm going to go 2D. I'm going to select bore. I'm going to click one of the cylindrical faces of the holes. And then I'm going to check select same diameter. And it's going to automatically find all of those holes. Then I'm just going to click OK. We're done. It's too easy. It's like drilling holes in a shot bot. It's not even a metaphor. Great. How's everybody doing? Cool. Also, like, you know, talk to each other. It's great. Oh, we haven't started yet. It looks like you have a few extras here. 1, 2. So instead of clicking this every time, you should go back in and you should edit the ones that already exist. Because you don't need multiple. You can delete the older two. Sure. Go around. So go to 2D and then bore. And then click one of the holes. And then click select same diameter. Cool, look up. So you have your bore set up. Cool. Great, next we're going to do the 3D. So we're going to do a 3D spiral. So if you click the 3D drop down, there's a lot of options here. I have only used a few of them, and a lot of them are useful. Some of them are not that useful. But in this case, since we're cutting something that's a circle, a spiral makes a lot of sense. It's just the most efficient way to cut a circle in the 3D space. There's also the morph spiral, which is like useful if something's not quite a circle. And the radial, which is useful if you want your tool paths to look a certain way. Because like these are going to leave marks on your part. So what decisions you use in the 3D space actually affect how it's going to look before you sand it. So sometimes people use things that look a certain way, or whatever. But we're going to use spiral for this. And then just go ahead and click the circle around the dish. And notice the thing that's blue is the thing it's asking you for. So right now it's asking you for the center point, and it kind of guesses you want this one, so you can just go ahead and click it. And if we click OK now, we have this horrible problem. We're like, yeah, it looks great until it gets to here, and then it's like, what the hell are you doing? So if you go back into Edit, we want to add, under Geometry, we want to add a machining boundary of a selection, and that selection is the same circle. Now if I click OK, you can see it's doing reasonable things. It's still got two problems. What problems does it have? Yeah, it's starting in the middle, which means it's plunging. And somebody else, I think, had said step over. That the step over is really wide. It's going to be a really ugly part. So we go back into here and we do Edit. Inside, outside direction. Right now it's set to don't care, but I do care. And for step over, I'm going to make this 1 millimeter. So I changed inside, outside direction under spiral passes to outside to in. And I changed the step over to 1 millimeter. Now if I push enter, you can see it's much tighter, and also it's starting in the end. You can see the arrows. And I'm also going to do an additional offset of negative 0.25 inches. Because the bit is half an inch in diameter, and we want to start half that inward so it doesn't waste time doing nothing. Because I'm going to simulate it to show you what I mean, and I'm going to pause it. Until the bit gets to this point, it can't cut. It can't go down any further. You know, it has to be on the inside of the line. But yeah, now it's doing stuff. And at the end, it's going to look like that. Not too fancy, but you know, what are we going to do? It's for paper clips. Paper clips don't need a fancy home. So again, I'm going to start that whole thing over. I'm going to delete my spiral operation. I'm going to go 3D spiral. It assumes I'm using the same tool, so I don't need to pick a tool. But for geometry, you can see the blue thing is like, hey, what do you want to machine? I want to machine that center point with a machining boundary of this circle also. Oh, sorry. Instead of that offset, we can just do tool inside boundary. That's way better. Let's do math. Tool inside boundary. So forget that stuff I said about negative quarter inch. And then for this, we're going to do outside to in because we do care. And the step over is going to be 1 millimeter. Doing it one more time. So 3D, because it's a 3D operation, we're going to use spiral. It assumes we're using the same tool as before. But if we go over to geometry, you can see it's waiting for our center point. So I can click this circle, and then click that point, and then that satisfies the center point. But for machining boundary, we don't want to do a silhouette. We want to do a selection. And that selection is the same circle. And tool center on boundary? No, we want tool inside boundary.
And you say additional offset minus.
I did that last time, but I didn't realize there was a tool inside boundary option, which is way better because it's just one click. I was doing the math for it. So if you go right click it and do edit, second tab, the tool inside. There you go. Now click OK. And now you see it's going to do a lot less work. Just doing more things. CNC is so much fun. Sure. So in the second tab here, go ahead and create a circle. There's the edge of it. And then you have to click it. And then instead of silhouette selection, and then circle the edge. And then into the tool segment boundary, tool inside boundary. And then in the fourth tab, one more. Instead of going there, I just started outside in. Instead of 6.25 to step over, 1. Cool. So the 1 is the distance between the two lines. The inside boundary keeps it from wasting time when it's not touching anything yet. And the outside boundary shows us the line. Cool. So right click it and click edit. And then the second tab, blue tab, tool, instead of tool center on boundary, that one lower? Yeah. Instead of that, do inside boundary. No, not. Perfect. Great. Okay. Cool. Yes. The edge, really? Because we're doing inside boundary. If you do center on edge, it doesn't actually start cutting until then anyway. Because it can't go down until its edge is inside that circle. That's right. Yeah. So the reason why it doesn't start on the edge. Oops. 1. Outside in. Inside boundary. The reason why it starts here is if we go to simulate, inspect, section analysis. If we go to simulate, it can't actually go down in the cup until it gets past that point. It's coming. There it goes. Oh, come on. No. Spiral. Play. It's coming. There it goes. Okay. Until it gets to that point, there's no reason for it to go down. So when it was starting on the edge, it was just doing nothing for a bunch of rotations and wasting our time. But yeah, because those blue lines are the center of the bit, and the bit's pretty big. Cool. Ooh, I'm lost. Awesome. So now we've done the 2D pocket, we've done the bores, and we've done the spiral. The last one is the one we're going to do the most of for the ShopBot, which is 2D contour. So for this, it's usually best to click the bottom line. The top line also works, but the bottom's a little more consistent because that's the thing we want to cut. This little red arrow, I recommend never clicking this. This flips the inside and outside. Like, obviously you want to cut on the outside of this line. You can see my part. But for some reason, it gives you the option of clicking this secret unlabeled arrow that will flip it around and cut on the wrong side. But if I just click OK and then simulate it, it's pretty good. It's got some problems, but it's not. It's the default's not that bad. The things we want to change. So this is 1/2 inch material. If we were going with 3/4 inch material, we'd probably have to cut in 2 steps because you can't go much deeper than the thickness of the bit. So for 1/2 inch bit, you can go to 1/2 inch material, but for 3/4 inch material, it's really pushing it to do it in one pass. So don't follow this along, but if we had thicker material, you would have to do multiple depths and say maximum roughing step down of 0, let's just say 0.25 inches. And then it would do 2 passes so it wouldn't break the bit. One at halfway depth and the other one at full depth. But we don't need to do that today. So now we'll start following along. Today the things we want to change is we want to get rid of lead-ins and lead-outs always and replace them with ramps. And those ramps should be 10 degrees. So the linking tab, the last tab here, is where lead-ins and lead-outs live. We want to always turn off lead-ins and lead-outs. They're really something that's more useful for metal. Because when you're cutting metal, you're usually not cutting parts out of a sheet. You're usually cutting them out of a block. But lead-in and lead-outs, they have the problem of sometimes if you have many parts next to each other, your lead-in will destroy the part next to you. Because Fusion doesn't expect you to be cutting multiple parts out of a block, which is the way we're using it. Because most people using these features are machining metal. That is to say, most people paying for these features are machining metal. And those are the users who get more attention. But we don't pay for Fusion. We have shopbots, which aren't cheap, but they're not like Haas expensive. So ramping angle of 10 degrees. And now you'll see the difference is it ramps in with this red line instead of what it was doing before, where it was kind of coming in straight and then coming in sideways. Yeah, the other thing we're going to do is add tabs. So I'm going to start that over. I'm just going to do 2D, contour. I'm going to click the bottom edge of the part. And then I'm going to go to linking. I'm going to uncheck lead in, uncheck lead out, check ramp, and type 10 degrees. And now this is now I'm going to add tabs. The automatic tab positioning by distance is horrible. I'm always going to do at points. It doesn't seem horrible in this case, but it's so likely to mess you up, especially if you're cutting multiple parts out of the same sheet. Because if your tabs don't line up with a part on the opposite sheet, it's as if they don't exist. Your part will fly. I also don't like rectangular tabs. I like triangular tabs that are 1 inch wide and 0.2 inches tall. And the reason why I like triangular tabs is because then the bit ramps in and ramps out instead of plunging. So the bit lasts longer and you get a better surface quality on your part. Because in order to do a square tab, the bit has to stop, and then it's spending more time on one part of your part than on other parts of your part, and that can lead to burning or to overcutting. So I selected these 4 points. They're the points I recommend. Yeah, the other change I made is I turned off lead-ins and lead-outs, and I did a 10-degree ramp. I still don't trust it. 2 semesters ago, I drank a mouthful of that water and pulled something out of my mouth, and then I dumped out the water bottle, and it was like gray, like all the water was like black, and I was like, I drank half that bottle. So I'm gonna run to the water fountain, and I'll be back to check in as long as it takes to walk across the whole building. Oh, how are we doing? I think I'm just going to machine it with the unusable post-its because I don't want to interrupt Steve's class to ask how to fix that plunge problem. But even with the divot, oh yeah. Yeah. You know, I don't want to do a demo with a bad practice of the plunge. I don't know. Cool. If Jolly's class is gone, we can split them.
Yeah, they're done. They just walked.
All of it?
Yeah, I saw a bunch of people walk.
Cool. Hi. We might be able to machine some of these today. That would be amazing. Oh, I'm sorry, I forgot something about the contour. Go into contour. This actually isn't going to cut all the way through. So if I measure the material, and it's exactly 1/2 inch, it's a miracle of manufacturing. And I set the machine to cut to the bottom of the material, it's probably not going to cut all the way through because the machine could deflect both the head of the machine can deflect upwards and the bed of the machine can deflect downward. So we have this head-bed divergence. So the machine thinks it's at the bottom, but it's not quite at the bottom. It might only be 1/3 of a millimeter or something. It might be tiny. But it's good practice to always, in your contours, you go to Edit and you go to Heights. Heights. I think that there should be a law against icon-only buttons. It's the worst. It's just like, I'm never going to use this often enough to know what these icons mean. And the bottom height, instead of selected contour, we're going to do we're going to do an offset of negative 0.5 millimeters. You can also do negative 20 thousandths of an inch if that's your preference. And now you see it's just a little smidge below the bottom of the material. And that's important because you want it to actually cut through. And every semester we've refaced the machine so that the bed is flat. That's weird. So yeah, Edit, Heights, bottom height, offset, negative 0.5 millimeters. just a little bit. It's like 3 or 4 pieces of paper worth of thickness.